You've been told that brain decline is linked to a lack of iron, copper, or zinc, but that's not the whole story. The shocking truth is, one of the earliest signs of cognitive decline, a precursor to Alzheimer's, is linked to a deficiency of just one metal most people completely overlook: lithium. This condition, known as mild cognitive impairment, affects countless people over 50, often without them even realizing it's the first critical domino to fall. You're about to discover the specific ways a lack of this single element can secretly sabotage your memory, thinking speed, and even your longevity. And that's exactly what we'll uncover today. I'm Professor Vitalis, and in my years of research, this finding is one of the most crucial for understanding brain aging. First, let's be clear. Mild cognitive impairment is a decline in memory, reaction speed, and the ability to learn new things. People with it can still lead independent lives, they can work, and they can even vote. But it's just not the same level of mental sharpness, and this decline often starts to become noticeable to others after 60, and sometimes even after 50. The real tragedy is this. About 50% of people with mild cognitive impairment will eventually progress to the full-blown disease we call Alzheimer's. Alzheimer's is a devastating condition where proteins, called tau and beta amyloid, build up inside the brain's nerve cells. These proteins block normal nerve signals, prevent proper memory function, and trigger dangerous inflammation in the brain tissue, which ultimately leads to severe consequences. In a recently published study in the journal Nature, scientists decided to investigate which metals are deficient in people with mild cognitive impairment and Alzheimer's. They tested 27 different metals. The results showed that only one metal had a statistically significant decline: lithium. This gave rise to a powerful new idea. Perhaps a lithium deficiency in brain cells is the very first link in the chain reaction that leads to mental decline and eventually to the development of Alzheimer's. They also discovered that the distribution of what little lithium was left inside the nerve cells was uneven. It was concentrated around the amyloid plaques, so this creates a bizarre situation where the cell is starving for lithium, yet the lithium it does have is all tied up with the amyloid plaques. It's similar to if you had a lot of money, but it was all stored behind an impenetrable concrete wall. The money is technically there, but you can't use it. In exactly the same way, amyloid plaques bind the lithium inside cells, making it scarce and unusable. To understand how a lithium deficiency leads to mental impairment, a study was done on mice where lithium was completely removed from their diet. This resulted in a 50% decrease of lithium in the brain. And in these mice, the connections between neurons, called synapses, began to break down. Remember this: these connections between nerve cells are what allow us to form memories. If we lack these connections, these synapses, we can't remember anything. In the lithium-deficient mice, a breakdown of the myelin sheaths around nerve fibers was also observed. Myelin sheaths are like the insulation on a wire. If a wire is left without insulation, the current flows poorly. In our case, the nerve impulse flows slower, and this manifests as slower reactions and a reduced speed of thought, and it was also shown that a lithium deficiency led to an accelerated deposit of beta amyloid and phosphorylated tau. It is precisely the combination of tau with phosphorus, a process called phosphorylation, that is one of the key links in the formation of Alzheimer's disease. And this process happens during a lithium deficiency. You see, a lack of lithium activates a special enzyme called GSK3-beta, and it's the activation of this enzyme that promotes the accumulation of phosphorylated tau. Another observation revealed that a lithium deficiency triggered inflammation inside the brain, and the cells to blame are called microglia. A lack of lithium activated microglia through an abnormal pathway, which in turn caused these cells to promote inflammation. It also turned out that a lithium deficiency switches on the exact same set of genes as those found in Alzheimer's disease. This is called a transcriptome. For a simple way to understand what a transcriptome is, imagine you have a library of music recordings. If you were to select just a few of the thousands of available recordings to create a playlist, That playlist would be your transcriptome. In this way, the transcriptome of a lithium-deprived cell began to look just like the transcriptome of a cell affected by Alzheimer's. But here's the part that truly rajuet me now. Researchers also noticed that correcting the lithium deficiency led to a halt in the age-related changes that develop in nerve cells. So what specific form of lithium was used? It turns out it was lithium orotate. Lithium orotate is an organic salt. Unlike lithium carbonate, it doesn't bind as strongly to the beta amyloid inside a diseased cell. And remember, in a sick cell, lithium was being trapped and held on pieces of beta amyloid. But lithium orotate doesn't get stuck there. It distributes evenly throughout the entire space of the nerve cell and, accordingly, performs its function there. Scientists tried several options and ultimately settled on lithium orotate, which I've talked about many times before. Of course, this may raise a question. Can these results from animal studies be applied to humans? And will we get the same benefit from using lithium? Well, there are already answers to that question, found in epidemiological studies that I've mentioned. These show that in regions where there is more lithium in the food and water, people live longer and have better cognitive abilities. Regarding the toxicity of lithium, some might ask about that. I've already explained that the lithium orotate used in supplements, by the way, Bryan Johnson uses it, I made a video about it, and I use lithium at 1 milligram. This is approximately 250 to 1,000 times less than the doses used in psychiatry to treat bipolar disorder. And just as in the experiments with mice, using lithium in such low concentrations in humans doesn't even affect the concentration of lithium in the blood. By the way, I'll note separately that the concentration of lithium in the blood and the concentration of lithium in the brain are not interconnected. So if you want to check how much lithium is in your brain, a blood test won't tell you anything. For that, you'd have to drill into the brain and take a piece of tissue. Well, if anyone wants to, of course. That's all for today. If you want to learn more about preserving your mental and physical health and how to age beautifully without succumbing to age-related changes, consider subscribing. I'm Professor Vitalis. Thank you for watching.